thank you everybody for coming this evening. My name is Ben Thompson. I am the past president for the Rocky Mountain American College of Sports Medicine region. Thank you for joining us on our first of our fall lecture series. We're really excited this fall to have this lecture series online and webinar so we can have a greater reach. And we're really excited with the panelists that we have throughout the semester. So our first one, as you can see, is Andrew Stuart, and he's going to be talking to us about his experience as a speed skater. And I'm going to let Tony Nunez, our treasurer for Rocky Mountain ACSM, introduce him. Thanks.
Thanks, Ben. As you mentioned, I am Tony Nunez. I am the treasurer of Rocky Mountain ACSM, and it's my pleasure to introduce Andrew Stuart to you today. Andrew and I actually spent some time together at the University of New Mexico for a little bit. So we did cross paths in the industry, but let me just give you a little spiel on Andrew. So he oversees the health and performance science and strength and conditioning services for the national team and developmental training program for US Speedskating. Andrew was the recipient of the 2019 USOPC Counsilman Science Award for addressing deficiencies in speed skating performance, utilizing dynamic strength index testing. Stuart is currently a PhD student at Charles University, where he is completing his doctoral studies, investigating the effect of different post-activation potentiation interventions on speed skating performance. So without further ado, Andrew, go ahead and take it away.
Thanks, Tony. I'm going to share this real quick with you all, and hopefully we can see that. So yeah, so my name is Andrew Stewart. Like Tony had mentioned before, I kind of oversee all the health and performance science and strength conditioning interventions initiatives with US Speedskating. So today I'm going to kind of talk to you all about that, kind of how we evaluate and individualize the health and performance in competitive speed skating. So really the objective here in this presentation is, one, provide a brief overview of speed skating. I don't know that many people that are knowledgeable about the sport of speed skating. It's kind of talking to the guys earlier. It's kind of an obscured sport. People only see it once every 4 years. So kind of dive into that, an overview of that, discuss kind of the needs analysis of the sport. There's some similarities with other sports and similar environments like hockey, but there's some other differences. We'll discuss kind of our philosophy that we have here of evaluating and individualizing health and performance. I'll touch on how all these kind of initiatives are integrated, and how we kind of individualize things for athletes. And then lastly, kind of how we connect the dots amongst staff members and departments. So first off, overview of speed skating. It's a very unique sport, originated in the Netherlands in the 13th century. That's why the Netherlands are our biggest adversary internationally. They've been doing it since the dawn of time, basically. But it first appeared in the 1924 Winter Olympic Games, and from that point on, it's been there ever since. So this is actually Joey Mantilla, who is actually one of our three-time Olympian, getting ready for his 4th Olympic Games this coming February. There are several different specialities within the sport of speed skating. So we have long track, which is what Joey's doing. We have short track, which most people would understand with Apollo Ono, and we have marathon skating. Long track is a time trial-based sport, and it actually requires the athlete to compete against a clock rather than another individual. Although they are paired together, and there is some level of human competition, it's really they're racing the clock. The distances within long track speed skating, on the sprint side, we have a 500 meter, 1,000 meter, 1,500 meter, which is kind of an in-between distance where some people in the distance side of things skate those, and some from the sprint side skate that as well. On the distance side, we have 3K, 5K, 10K. And there's a couple of new events that have been coming up since the last Olympic Games. One of those is team pursuit, which the United States women's team actually won bronze at last Winter Olympic Games. Team sprint, which is a new one that just started up at the start of this quad, and mass start, which was originally planned for last Olympic Games, but I don't think they actually started it up until this quad. Short track is the other side of things that we deal mainly with. Short track speed skating is a lot different than long track. It's more of a pack style based sport. It requires the athlete to perform multiple heats of the same distance over the competitive day. So with short track, they start in the morning, they skate the 500 meter, they'll go through all the heat rounds, they'll go through all the quarter rounds, they'll go through all the semi rounds, and then they'll go through the final rounds. So you're looking at a skater having to do at least 4 sets of 500 meter distances. So it turns into a pretty long day. And then World Cups, we would get there at 6 a.m. and we wouldn't leave until last bus would be 10 p.m. So a full day of racing. The distances that short track competes in is very similar to long track. However, there is a relay component for those longer distance races. And those relay components consist of 4 individual males and 4 individual females. And those become relay teams. And then there's another new relay that is coming into this games, which is called a mixed gender relay, which is 2 females and 2 males. Looking at kind of the movement patterns and needs analysis of speed skating, the main goal in speed skating is to maintain a high power output over the entire duration of competitive distance. The start of the race, and again, this is dependent on the event that they're racing, mimics a track start. So the athlete is it's got to use a lot of force and high anaerobic work initially to accelerate off the line during the start. And the skater is going to basically shift into 3 different phases of stroke. So there's the glide phase, the push-off phase, the reposition phase. And so as the skater glides forward, they're actually not able to effectively generate enough propulsion by pushing backwards. So as you can see here with Brittany Bowe, who is our world champion and top medal contender right now for the United States, you can see how she's pushing off. She's in a glide phase, and then she's going to reposition by swinging that leg back and through, and then pushing off of the right foot. And so in that push-off phase, what this allows the skater to do is propel themselves forward in a right angle relative to their gliding motion. And that creates this kind of sideward push. And that's what's resulting in that forward movement, kind of what I was just discussing with you. While the cycling is happening between lower limbs, the trunk position, as you can see here with Brittany, is at 15 degrees. And this is held throughout the entire race to minimize any loss in speed due to air friction. So if you think about this, they're having to hold this position. They're having to be in an occluded position. There is buildup of metabolites. There is a lot of pain, a lot of burning, and they're having to do this repeatedly over time. And so it gets pretty challenging. This push off is performed mainly from the knee and hip extensors. And so that is one major muscle, like knee and hip extensors are major muscle groups that we utilize in our training. The hip and knee complex is not actually fully extended when they're skating and they're proceeding to the next stroke. So if you can look at this picture, Brittany's left knee is not actually straight. It's actually still bent. She doesn't fully extend that push off. And so this push off phase, the skaters will use this to kind of create that acceleration in that posterior lateral plane. And so again, hip extensors, abductors, they generate the movement. And as they shift to this gliding phase that Brittany's kind of in right now, the hip and knee flexors and extensors co-contract to maintain stability and balance. So kind of giving you a little bit of a breakdown of kind of energy system requirements. This is actually the first paper of my publication. But what we did was we broke down kind of the pacing and energy system considerations. And as you can see, speed skaters, they're booking it when they're on the ice. Like I was telling Tony earlier, we could see speeds up to 40 miles an hour on ice in some of these distances and with some of these skaters. And so in the 500, 1,000, we're really talking about something that's lasting 30 to a minute 15. And in the 1500, we're looking at, just under 2 minutes of an effort, full out effort. And so what we see, or what we found in the literature, is that in the sport of speed skating, both aerobic and anaerobic mechanisms are used to deliver and sustain these high power outputs. And there's a combination, and it varies in respect to that competitive distance. And the pacing strategy, which is really, really important, plays a key role in this. And so one strategy that's been observed internationally is this idea of initial rapid acceleration. So people are taking off, full go, gas pedal down. I'm going to go as hard as I can. And I'm going to let my peak power during the first lap be utilized all the way up, and utilize my anaerobic speed reserve and maximum anaerobic power to finish out the remainder of this race. And that's kind of the pacing strategy that has become the most dominant in the sport. The next thing we'll talk about, again, just kind of giving you a brief overview of these things with the sport, is the potential injury side. And again, this kind of comes from, again, my first publication that I did for my PhD, looking at basically loading sources, risk factors that are associated with speed skating. And so in the sport of speed skating, like I've mentioned, they're moving at very high speeds, but they're having to have the proprioception to balance on a blade as thin as 1/8 of an inch. And to be honest with you, injury is not uncommon. We see a lot of injuries that happen. The most gruesome ones are lacerations, which depending on the different disciplines are pretty frequent. But there was a publication by Quinn and his colleagues in 2001 that actually investigated the injuries experienced in a single short track speed skating season. Again, with this population, there's not a ton of publications, and so we kind of have to, take what we're given sometimes. But of the 111 injuries that they recorded, the knee, ankle, spine, leg, and groin were the most common injuries or injury areas. And that's actually really common with other sports like hockey that utilize kind of the same push off, glide, reposition phases as speed skating. And so what they kind of found was acute on ice and off ice training accounted for nearly 60% of all injuries, and most frequently resulted in time loss. And that time loss can be up to, just over 2 weeks of time lost of training, which in a sport like speed skating is very detrimental, because speed skaters, like athletes in speed skating, they need to feel the ice. They need to be able to have that feel of the ice in their blade and how they position their blade and how they push into the ice. Taking 2 weeks off is basically killing them. They can't live without that feel. Ankle sprains accounted for 12% of the recorded injuries. Groins, 9%. Knee problems, which is kind of obscured, but we can imagine what different ligaments and things of that nature are probably getting messed up. But 33%, spine 22%. And again, thinking back to that picture that you saw with Brittany and Joey and Kristen with short track, they're having to be in that crouched position. They're having to hold that position. They're never actually able to extend fully. That leaks into other aspects of off ice training, where they're doing, like I have here, static dry land, increased lap volume, intensive plyometric sessions. It kind of throws a lot of red flags there. So these are kind of the main sources of training injury, but it's not the all-encompassing list. So now we get into the application side of things, and so everybody can just take a deep breath now. And we got past the lecture on speed skating performance, but what we need to look at now is kind of how we are evaluating and individualizing this health and performance. And so our philosophy is very simple. We want to collect meaningful data that provides a snapshot of different aspects of performance and health. And that can be physiologically, mental, nutrition. It could be from the coaches, the technical, tactical side. We want to collect meaningful data. We want to be able to provide feedback to the athletes. And that's something that the athletes were very vocal about when I first got here, is if they're going to do something, we're going to ask them to do something, we're going to ask them to track something, they want to be able to see that information, and they want to be able to see it applied to their programs. So they are our number one stockholder in everything that we do. So we have to be able to provide them feedback. But by providing them that feedback, we can kind of show the positives of their actions, which will increase their intrinsic motivation and their buy-in. One of the other things is that we show them their deficiencies. So we say, hey, on this measurement or this technology that we're using, you're in the bottom third of your team. This is how we're going to address that. And it creates this ownership in their programming and execution of the plan that we come up with. But again, it goes back to that intrinsic motivation. They don't want to be dead last. If they're not first, they're last. I have a bunch of Ricky Bobbies. So through this integration of health and performance, we can apply changes to the programming and enhance performance through integrating and assessing. So again, our philosophy, evaluation and training is a cyclical process. We start with our assessments. We look at where we are in our calendar and what our goals are in that calendar. And it's not just in the weight room. It's not just in nutrition. It's for everything, every single aspect of support. We look at program design and structure. So how do we structure these things within a weekly on ice, off ice training program? We look at using sport technologies to have objective, measurable goals. We look at applying and monitoring these things. And then lastly, we look at the performance markers. And those performance markers may not be, hey, they improved their peak power by X amount. It may just be they're able to stay with the team in a certain exercise or a certain workout. So how these kind of integrate, like I kind of told you, everything is really moving. I kind of say it's always moving the needle forward. So we'll start with health. Health goes into performance. Performance and health go into applied performance and science. So on our health side, we look at injury, health, and history, our needs analysis for the sport, movement-based assessments, nutrition and mental assessments. We look at performance. Obviously, we have all of our performance assessments that we go through, and we look at potentiation protocols. And then that leads into this applied. We're applying all these things together to create this individualized training plan, this individualized rehab plan. We look at periodized seasonal injury reports. So we see correlation and predictives of those structural limitations and pain with days modified from training. We look at correlations and predictive analysis of off-ice performance markers and on-ice performance markers. We're always moving this into an applied direction. So how do we make it work? Well, first off, we, again, kind of going off of what I said, we make testing and assessing a part of training, not separating them and causing logistical nightmares. In return, what we kind of get is we get more buy-in from our key stockholders. So our coaches and our athletes. They're more likely to do them and provide better collaboration. We find way in and way out touch points that decrease the necessity of tracking down the athletes. The last thing that I want to do is have to go hound an athlete to fill out their morning report, and or just create another scheduling conflict for the coach. So we look at basically the weight room and ice are our most common places for all of our athletes. With the exception of one athlete, everyone comes and sees me in the weight room. And all 100% of our athletes go to ice every day. So those are our 2 points of contact. And then lastly, using phones, using our athlete management database, Smartabase, using that app on their phone, because everyone has their phone on them right now. I'm sure everybody has a phone near them right now. It's always on them. So that's how we kind of make it work. Looking at health and individualization. So first thing, like I showed earlier, injury health history. It's just your standard PAR-Q, history of injury, physicals, nothing too fancy, nothing too crazy. The next step is we look at movement-based assessments, as you can see here with Ethan. So what we do is we look at the needs analysis of the sport. We do a movement screening. We look at concussion screening because that's a real actual injury that occurs a little bit more frequently in short track, but can occur in long track. We look at this screening and it's broken down for team normative data. So we start with a team approach, long track, short track, and then we break it down distance specific within those teams. So we take percentile ranking and normative distribution, which is something easy you can do in Excel. And we establish what top, middle, and bottom third grouping looks like. And we allow for our interventions and individualizations off of those groupings. We look at nutrition assessments, and this is really big. Again, we just look at baseline intake forms, and that gives us an idea of an athlete's eating behavior. We utilize ISAC anthropometric assessment to determine interventions based off of our previous quads normative data. And this allows for an understanding of fluctuation based on the time of year and training phase and et cetera. So, you may get, an athlete who is a little bit self-conscious about their body, the body mass that they may be putting on during the summer, when we can just sit down there and be like, hey, it's okay. We know that you're going to increase your body mass a little bit because you're training right now and your body just needs to fuel properly for those trainings. But we know that you're going to lean out as you get closer to the competitive season. Last thing is mental health. And when we look at that, we're basically determining the athlete's mental health, rituals that they use, and mental skill level that they have. This again allows for this kind of individualizing pre-race and training mental skills that can be utilized for their performance. Now we get into my side of things. So hopefully this is a little bit more intriguing for all of you. So for performance individualization, we start with dynamic strength index. As Tony mentioned, I was the Counsilman award winner for using dynamic strength index to basically identify deficiencies. And so basically dynamic strength index, if you're not too familiar with it, is basically just the ratio between applying force dynamically, which you see here, versus applying force isometrically to interpret the dynamic strength deficit. So examining this ratio can give us the ability to see how someone's translating their maximal force capabilities into explosive performance. It's reliable. It's a reliable mean of understanding and assessing strength qualities. It's a valid means of detecting training-induced changes. It's very, very sensitive to the training that you do. We generate normative values for, again, specific athlete groups. We identify areas of weakness, and we guide training interventions from that. One of the big things that I had to learn is that DSI and the score, that DSI ratio score, has to be contextualized using other additional performance data so that we understand, we get a better picture of what the athlete is actually capable of and how they actually can translate that into their actual sports skill versus just a weight room based measurement. Again, we look at percent ranking and normative distribution, come up with our grouping, and then we're able to actually create individualized training programs off of that. We also utilize the eccentric utilization ratio. So we're just looking at the ratio between counter movement jump height and squat jump height. As you can see there from Mame, it just provides us a better insight into the athlete stretch shortening cycle ability. So an ideal eccentric utilization ratio is we're looking at about a 10%. CMJ is 10% of the SJ, or 10% more than SJ. So if the athlete is below 10%, we're looking at needing more strength training and higher impulse jumping. If they're above, we're looking at more plyometric, reactive, explosive training. And if they're equal, then they're kind of optimal. And so we can use a mixture of those kind of jumps. moving a little bit more further down the rabbit hole, we use velocity profiling with our squats. So we use GymAware. We profile, and it allows us to measure and evaluate their force velocity relationships. We use velocity-based training. It's a great tool. You can use it in conjunction with other methods such as percent 1RM and reps in reserve, RPE. I utilize all of those things as one. And so you can kind of see this nice chart that everybody's probably seen before. However, our goal is to provide a little bit more of an optimal training environment on any given day for the athlete. So with this in mind, we can actually individually prescribe velocities based off of their 1RM, velocity 1RM, in conjunction with that percent RM. So you kind of see this chart down here in the bottom side of the screen. Basically, what we've done is those percentages basically go along with the athlete's velocity 1RM. And what I kind of found out is this 100%. If we look at the literature and we look at the things that have been published by Dr. Brian Mann and John Weekly, we see that there's this velocity 1RM of 0.30. We can kind of see it gets down to 0.30 when you get to 100%. But what you can see here is if we say we're going to go for a 1 RM for that day, and I prescribe that for that athlete, if I say 3.0 or 0.30, excuse me, meters per second is our cutoff, well, I'm doing this athlete a disservice because theirs is actually at 0.22 meters per second. So they're actually not really performing close to that. They're only at 92%. Whereas if I have an athlete who is at 0.32 meters per second or 3.5 meters per second, and we're going to 100% at 0.30, I'm going too hard for them. So it makes very, very individually based. The next step is we take a step outside of the weight room and we look at power, force, and velocity sprint profiling. So there you can see some of our long track athletes. We sprint off ice just like we sprint on ice. So basically what we're trying to do with this profiling is we're just looking at the relationship between force velocity and power velocity from Dr. J.B. Moran's work. It just allows us for more individualized and accurate evaluations, monitoring, and training. From the data collection, we can identify how an athlete's using their weight room abilities and a similar or identical sport-related skill. So this idea of transfer training, because you can get someone really, really strong in the weight room. You get an athlete really, really strong in the weight room, but if they can't transfer that to the pitch or to the ice or what have you, then you're not really doing anything. And if you're basing all of your stuff off of just that metric, weight room metric, then you're missing something. So again, just like I've talked about before, we percent rank, we look at normative distribution, we break it down into our 3 groups, and that helps us individualize. Within that kind of profiling, we also look at load velocity sprint profiling. So we utilize the 1080 sprint, and what we look at is basically just the same as our barbell movements. We want to profile the athlete in their sprinting efforts. So we use a very simple protocol of 3x20 meter sprints. Right now we're using 3 loads of 5, 10, and 15 kilos. We are discussing moving that up a little bit more to get a little bit more of a resistance and get a little bit of better picture. We use the velocity decrement method by Cahill and his colleagues in their paper. We can utilize basically individual loads and speeds in conjunction with those identified deficiencies from the other performance assessments. So we look at load velocity profiling, we look at DSI, we look at eccentric utilization, we look at sprint profiling. You know, we can identify these kind of deficiencies that these athletes have and utilize this kind of loaded sprinting in conjunction with that. It also allows us the opportunity to understand asymmetry differences in these kind of semi-sport or sport-related movements. So what you can kind of see here, this is from the 1080 sprint. So what we can do is we're going to get basically a breakdown of every 5 meters of that sprint. And we're going to be able to get total time, section time, the distance that they're at. We're going to be able to get their peak and average watts while they're in each one of those segments. We're going to be able to get force as well and velocity as well. And one particular interesting piece here is time to 90% of peak. And so that kind of is a new concept that we're kind of looking into right now, where we're looking at, is that a big defining factor between athletes? And like I said, asymmetry wise, we can break down these segments and see left versus right asymmetry percent. So once we do this load velocity sprint profiling, again, we can very much individualize not only the load that we're using but the speeds that we want to hit for specific people. So if we profile everyone and we look at everything and we take this into consideration with all of our other performance assessments, we can see, if someone needs strength, we're going to use a velocity decrement of 70%. So here you can see athlete A, B, and C all have, with their velocity decrement of 70%, all have the same speed. However, if we look over here on our loads, they all have different loads that they have to use. So what this does is it, again, individualizes to a T the specific needs and deficiencies of the athlete. So how do we put this all together? Well, this is a very nice chart that will kind of help you. I know I threw off, percent ranking and normative distribution and all this other kind of stuff. This is a very simple and easy chart for us to kind of comprehend those things. So we look at, as our priority measurement, we look at our dynamic strength index. But to refine that process down just a little bit more, and this is something that I had a problem with when I first started doing this, is I looked at just the dynamic strength index. I wasn't looking at some sort of assessment of their semi-sport skill or actual sport skill to really refine that process down. So what we see here is this kind of refining the process of, okay, we have our dynamic strength index. Somebody is greater than 0.8, which means that they are very force deficient. They need to get stronger, basically. So in the past, I would just go straight into a force bias program. But now when we look at this kind of sprint profiling, what we look at is if this individual has a force max in their sprint profile and it's at the top third of the team, of the group, they actually don't need force. They actually need a balanced program. They need to learn how to utilize that force in a more ballistic manner, more power-based manner. And likewise here, where we have an individual who is between 0.6 and 0.8 on their DSI ratio, that means that in the past, they would be very balanced. So they're not weak and they're not slow. But if we look at this, and if they're at the bottom third of the team in their force output in the sprint, they actually need to get stronger. So this is just a concept, again, where we're taking all these performance assessments in, but we really have to figure out, how does this actually apply to their sport? Is it just a weight room based measurement and that's where it stays? And if that's the case, then that's being in a silo, and we don't hang out in silos. Everything works in conjunction with each other. So as you can kind of see, again, this dynamic strength index and this profile determine what our resistance training emphasis is going to be. And then our assessments for asymmetry, movement screening, etc., will dictate what kind of prehab rehab side area that they'll end up having. So with that being said, with all that we have collected, we have a multitude of program designs and structures within one team's training session. So here are 4 very different but somewhat similar athletes, And so what we see here is we have athlete 1 whose DSI is 0.82. Their force is at their force max on the sprint is at the very bottom. Their velocity is at mid-third. Their eccentric utilization is above 10%. So they need a force-based program, a strength-based program that's going to use a descending exercise order. So force velocity curve from force down to velocity. So they're going to start 85% or higher, speeds of 3.0 to 5.0 meters per second. They're going to work down the chain to lighter loads, faster speeds. They would utilize, in sprinting, they would utilize 7% velocity decrement and focus on acceleration phase of sprinting. And they would also use, on a separate day, contrast with 10% of the velocity decrement. Reactive jumps and left side hamstring asymmetry protocol, because that's what they needed. So you can kind of go through this. Again, everyone is getting a very individualized training approach. What we see is, here's a good example. You have this individual is going to be in a force program, and you see here their DSI ratio is 0.7. Well, that's right in the middle. Well, yes, it is, but their force is at the bottom third. So they actually need to get stronger. And that strength is probably going to be the big indicator for them. But if we look at their eccentric utilization, they're right at 10%. So they would actually use mixed jumping. This athlete in particular is probably still very much a novice and still is very young and needs to develop. But something similar to the first individual that we talked about. In the middle, we have our balance program. Even though this individual is at a higher DSI, their force is at top third, velocity is in mid third. They need a balanced program. They need to learn how to apply in a more powerful manner. And so you can also see here with the speed program, right in the dead middle, force is at the top, velocity is in mid. They need to work on bringing up that velocity. So you'll see in their sprinting, 25% velocity decrement, we're focusing on max velocity. They're going to use assisted or varied resistance, contrast with 10% velocity decrement. And they're going to touch just a little bit of strength work, just to retain that attribute a little bit. So last thing, I won't bore you too much more, but I talked about connecting the dots within the departments. And this is a very big thing that I am pushing forward with here at US Speedskating, because as I mentioned earlier, we can't stay in silos. We have to branch out. And by branching out, we're creating a better environment for the athlete to perform. But one of the problems that we have had come up here in the last couple of months is trying to understand why an athlete can't hold their track at max velocity. So to set the scene for you, the athlete is skating. They're doing a 2-lap build into a 3-lap progressive acceleration. So they should build speed as the laps continue. So that split time should go down. And they should be hitting pretty fast max speed. So somewhere, again, between 35 to 40 miles an hour, 32 to 40 miles an hour. But for some reason, this athlete can't hold their track. And so that raises this idea of, again, connecting the dots between the departments. So in S&C, what we look at is that individual's percent rank on eccentric components of performance and asymmetry, and also their relative lower body strength. So we use counter movement jump on the force plates. We look at that, those eccentric components, and also where they rank with their lower body strength. And then we go over to medical and we say, hey, does this individual come to you? How many days a week does this individual come to you and ask you for, flushes or manual therapy or what have you for posterior chain low back? And the medical provider will sits there and says almost every day, if not every other day. Okay. That's another kind of light bulb there. You go to the athlete and the coach and you ask them about their performance during that high speed, max speed cornering and acceleration. And the coach again says, hey, the athlete can't, whenever I say that, tell the athlete to sit, the athlete can't do it. They say they're going to fall. Go to the athlete, same thing. Okay. So what we're kind of finding, the connecting the dot moment, is athletes who have a low percent rank in lower body strength and eccentric jump metrics typically have lower lap splits and can't sit during their high speed cornering and acceleration. So what we did is, in the past, we would have coaches say, oh, it's just their technique. It's their technique. It's their technique. It can be, but there are other components that could also shine a light as to why that athlete is having that problem. And so again, we look at this athlete, this one in particular, they are dead last in their percent rank in the jumps and in their lower body strength. They're dead last in their lap split times during the kind of high speed and max speed cornering accelerations. We're just connecting the dots and bringing a bigger picture to the athlete and to the coach so that we can address this deficiency. And here in probably 15 minutes, I'll be able to sit down in front of my TV on YouTube and watch the athlete skate and hope that our work paid off. So I just want to say thank you all for letting me come in and kind of share this with you. Hopefully I didn't bore you too much at the start of this thing with just, speed skating specific requirements and demands. Hopefully you got something out of this in regards to performance and health and how those things kind of interweave together. But thank you all for letting me come and talk.
No, thank you, Andrew. I appreciate it. It's for me, it's really cool to see. I think lots of times we think strength and conditioning very old school, and it's really great to see, the physiological measurements and everything being added into this to really understand the athlete better and prescribe for them, to make them, to help them be at their peak. So I think that's fantastic that you're that it's going this way. So great. Yeah, so definitely had no idea about that sport, what they're saying in the chat. For PowerPoint, I don't know, we'll talk with Andrew in a little bit, and if anything can be made available afterwards, I'll let, if you're in attendance, I'll let you guys know. So you can take a look at that. Does anybody have any other questions for Andrew? Okay.
Yeah. How I kind of got into this field. So I am a ex-jock. I played college football at the University of Mississippi. And that was, so when I finished in 2010, because I had no more eligibility, I had a year left of school. And so I actually started interning with the football strength staff and the Olympic sports strength staff. And so getting into the field is actually very challenging. And I think sometimes people don't understand how challenging it could be. Basically, there was a lot of years where there was a 2-year period where I didn't have an income because I was trying to do these internships, and they're unpaid at the time. They've gotten a lot better. The profession has moved a lot further since then, but it's a very challenging profession to get into. But the biggest thing is making an impact wherever you are with whoever you are, and also reaching out constantly. I had an amazing opportunity. I had an opportunity to go to LSU Shreveport, which is USA Weightlifting and High Performance Center, with Dr. Kyle Pierce, who's one of the best sports scientists in the country. To tell you the truth, he's a gem that most people don't know about. But that helped me reach out to individuals at the Olympic Training Center in Chula Vista for the Rio Olympics. And that helped me get to New Mexico, and that helped me get to US Speedskating. So it's constantly reaching out, constantly trying to make an impact wherever you are, and just building your network.
See, I think a couple other questions. So official job title.
It's a very long one. So I'm the head of health and performance science and strength conditioning. So I'm the head health and performance science strength conditioning coordinator with US Speedskating. Very lengthy title. We're working on that. That's a work in progress title.
It makes sense though. I mean, health and performance, they really go hand in hand.
Yeah, and this idea of performance science is a new evolving branch, basically, right? So, you know, a lot of things that I do in the weight room, like I talked about here in these slides, is I'm running statistical analysis on a lot of this stuff. I'm looking at for potentiation protocols. I'm finding out if the athlete is actually, you know, a responder to it. It's not just hey, we're gonna do 3 sets of 5 on back squat today. There's a lot of other kind of statistical and higher order thinking processes that have to go into this kind of stuff. 4-year macro plan and periodization, or yearly. So Bruce, great question. Yes to both. So I definitely look at yearly plan, but basically my yearly planning is in sections for 4-year planning. So yeah, so I sat down and I looked at the landscape my first year to figure out what 4 years looked like. And the thing is that in most years, except for this year, and obviously last year because of COVID, everything is in a very simple like rhythm. So for example, like I know that I get the most amount of time with the athletes, the most uninterrupted time in the summer months. So mid-April all the way until July or August in some cases. And that's like my biggest time to train. And that's going to happen every year. And so basically it's, you know, once ice gets in, that's where I have to really kind of like dial things down a little bit. But looking at that, so every April to August, every year inside of that 4 years is my biggest go time. So yeah, I use both of those. Yeah.
Let's see. And then Evan also had a question about biggest surprise about working with speed skating that maybe people don't know about.
Yeah, the sport is very surprising. The amount of the sheer willpower that someone has to go do a 10K and hold that position for that long amazes me. The other thing is also like watching world records get made and broken by your athletes. You're like, how are you going that fast on the ice, like, and not falling? But something that's really interesting is just the amount of just general training that they do. So the different training modalities that they do. So when I said like April to August is my biggest time, that's also their biggest time of training. So they're doing, for example, the short track team would do 2 hours of ice, and then they would do a 2-hour dry land session of jumping and holding skate position and balancing in skate position. And then they would get a 2-hour break, and then they would come to me for weights. And that was all in one day. And then the next day it would be a cycle. They would go and like cycle up, you know, up elevation to Park City. And it's amazing, like the amount of just general physical preparedness that they go through just to be able, for long track, just skate one distance a day. And then for short track to skate, you know, again, they go through all the heats and the rounds, they're skating a single distance 4 or 5 times. It's a full day thing. So just the amount of just extensive training that they go through just to do something that's, like I showed you on that chart, you know, 30 to 2 minutes long.
Andrew, thanks for kind of proving to some of the students that are in attendance today that you do actually use a lot of what you learn in classes right? This is all coming back, exercise physiology, advanced strength and conditioning principles. One question I have for you, since I'm able to ask live and don't have to write it in, with all that training that they do on a daily basis, how do you address overtraining? Or is that part of what you have to do, or is that a coach's perspective? How do you go about addressing that?
It's a blend. It's a blend. So one of the beautiful things that we do here is we meet basically on a weekly basis, and it's called a PET meeting, a performance enhancement team meeting. And so basically in that meeting, we have all of the disciplines and the coaches and the program directors and our high performance director in those meetings with us. And basically what we do is any athlete, again, we use an athlete data management software, SmarterBase. What we can do is we have all of our wellness questionnaires go into there. We have all of our force plate information being uploaded to that. So we can create these kind of dashboards and these alarms and alerts when things aren't going right. So we can get updated information on the athlete. So the athlete wakes up from, not, doing whatever they were doing and not feeling great. They do their morning report, they do their wellness, they tell us what their HR is, they tell us what their heart rate variability is, they tell us those things. And if something is out of whack, I get an email alert. And so the first step is to talk with the athlete and look at that. The next step is to look at the trends that we see from all of that data that we collect, that they help collect for us, to understand, is this a normal training rhythm? Are they just going downhill? And then having that conversation with the coach and then saying to the coach, like, hey, is this planned? Is this what's supposed to happen? This individual may be getting hit harder than the others. So what do you want to do about that? But then in those performance team meetings, that's where we put it all on the table. We all sit there collectively and come up with a plan of action. I will say that we don't, in my 3.5 years of being here, we've only had one individual my first year that we were actually worried about that with. So it's kind of like I'm knocking on wood right now. You can't really hear that or see that, but I am. Fingers crossed. But yeah, that's something that I think we've done a great job of addressing. And over the 3.5 years I've been here, we've steadily seen a decline in days modified or trainings modified or serious injury that has occurred outside the normal injuries that could occur from speed skating. But that's one thing that we do to kind of combat that.
Great.
Awesome.
Real quick, we had in the Q&A from Mingyu, she was asking, could you talk a little bit about maybe some aerobic capacity evaluation in long distance speed skaters? Like, do you do VO2 max, lactate threshold?
Yes, we do.
And like on ice measurements too?
The on ice stuff is something that we've started dabbling into with one of our coaches. He actually started doing that with his team during the summer when they had training on ice, just to kind of get an understanding. And that's where, offline, we were talking about the millimoles, right? And someone was up at the 18. We had someone who was at 21 millimoles of lactate. That's something that we're starting to play around with, but haven't really, kind of come up with a concrete protocol for. But yes, our short track team did VO2 maxes for the first 3 years. We got a new coach in this May. And so that coach shifted over to thresholds. But yes, we use thresholds. We use Wingate. We look at Wingate 6 second, Wingate 30 second. We look at obviously our lactic thresholds. We have done a FTP before. Because of COVID, we had to find a new way of doing some of this stuff. So we've done an FTP before. But yeah, we look at all those things. And again, it's the same process and the same idea, right? Is like, we want to look at basically where does this athlete stack up, looking at the past 4 years, and then also looking at where they stack up right now with their team. Do they need to address this? And then the next step is, if they're deficient or they're not, in that top group that we think they should be, Is it because they need to be, or is it because they just like they're a 500-meter skater and they don't need to worry about that? So, yep.
Cool. That's great. Does anybody have any other questions for Andrew? Nope. Maybe people are madly typing. Don't know.
I will say this, again, back into the profession side of things. Start getting out there, start interning, start doing things, start making a contribution wherever you are. It doesn't matter if it's a big school, small school. Understand that it's going to be a grind. At New Mexico, Tony and I have a mutual friend, and I was literally spending 12 hours a day in the weight room with athletes and then going to a PhD classes. So it's a grind, and doesn't mean that all universities or all places are like that, but there is that to it as well.
Great. Good advice. Thank you. Well, I think that is it. Before we go, just a real quick to those of you that are on, we greatly appreciate you attending. You're going to get a little email asking to fill out a short little survey about the webinar when you're done. If you could just please fill that out, we'd appreciate it. But Andrew, thank you for taking time this evening and speaking with us. It was really interesting and great to hear about what you're doing and the new things that you're doing with US Speedskating. Thank you for coming. Thank you.
Thank you.
Thank you, Andrew. Appreciate it.
Yep.
Thank you.
Thanks, everybody. Appreciate everybody coming, and we'll see you later. Thanks, everybody.